Sorry about that. I think my Skype crashed. Sorry, I think my Skype crashed there. Yeah, so how do we do this one?
That's going to be circle theorem. Not really sure. So would you? How does this tend to work out the area decision? So first you'd have to do pi r squared.
Yeah.
Find the area of the whole circle.
How would you find the area of just the sector?
Just this sector. You would first you'd have to work out the angle that's at.
Yes. So how do you do that?
I'm trying to think. Not completely sure.
What would be the length of O to B?
Oh, that's 16 as well. Okay, yeah. So you have all three lengths, and you could do. No, I'm not sure.
So you have all three lengths, and you need an angle, and so in that case, you would use cosine rule.
Cosine.
Yeah.
Okay then. So that will be 16 square. 8. Okay, first write down the rule. A squared is equal to b squared plus c squared minus 2bc cos a.
Yeah.
And then we have to do the rearranged one so that we get the angle, which would be, isn't it, minus b. I'm trying to remember it.
So you could just rearrange it, or you could sum in the numbers and rearrange.
So you'd minus b squared and c squared over.
Yeah.
So it's a squared minus b squared plus c squared.
Minus c squared.
Plus 2bc.
Well, let's just say equals minus 2bc cos a.
Yeah.
And so how do you get cos a?
You have to divide by minus 2bc.
Yeah. Okay, so what side is what?
So 28 squared.
Yeah.
Minus 16 squared minus 16 squared again. Divided by minus 2 times 16 times 16.
Yeah.
Gives you minus 34,000, and then you reverse cos that?
Should not be minus 34,000.
No, that is not right.
I think I know what you did. Did you put minus 16 squared? Is that in a bracket?
No, I didn't put them in brackets.
Should it be in a bracket?
28. minus.
I think those are supposed to be in a bracket.
No, I think it's supposed to be 28 minus bracket 16 squared bracket minus 16 squared again.
Okay, so I'll try without bracket and just see what happens.
Oh no, it's the same.
Oh, on the bottom is 2 minus 16s, isn't it? Oh, that should get you the same thing though. No. On the bottom, it's just normal 16. I get something totally different. Minus 17 over 32.
It's a bit weird. I am in the right function for my yeah, I am.
Are you? Do you have degrees or radians?
Yeah, that's what I was just checking. But it's fine. So let me try it one more time. 28 squared minus 16 squared. All over minus 2 times 16 times 6. Okay, now I get it for some reason.
Right.
Minus 0.53. And then reverse cos of the answer is 122 degrees. And so, then we do that.
Do the working out to 5 sig fig.
It's 5 sig fig. Okay, so 122 degrees.
So 122.1
0.
I believe it'd be 0.9. You only round the very last one.
Off. Okay. All right then.
Okay.
Yeah.
Go on.
And then 122.09 over 360 times 6 times pi times 16 squared finds the area of that sector, which is 272.75. And then you have to work out the triangle's area, which you could use the sine rule, half A sine C.
Yeah.
So 0.5 times 16 times 16 times sine 122.09. Gives you 108.44, and then you do 272.75 take away 108.44 leaves you the area of 164.31.
Hold on. Yeah, so the trick there is that O to B is also a radius, so it's also 16. And to find the angle, you need to use the cosine rule because you know 3 sides. Any questions there?
No, that's good.
Okay. How about let me come back to that in a sec. This one. Yeah, how do we do this?
So triangle BC. So you could do the sine rule to work out the area and then just rearrange it to find AB and then use the cos rule to find AC. So 50 centimeters is equal to half times 12.3 times AB times sine 73. Then you have to rearrange, so divide by a half times 12.3 and sine 73. Could you do that?
Yeah.
So 50 divided by half times 12.3 times sine 73 gives you a big number.
Is it 8.50155589?
No.
Did you, when you divided, did you put it in a bracket?
All of
So
well,
50.
all of the. No, I did not. Wait. Yeah, I've got 8.5 now.
Yeah, so that's like saying 50 over that is what it
Yeah.
would be.
Okay then. All right.
8.50. So what would this round to 5 sig fig?
To 5 sig fig. 8.5016.
That's it. Okay.
And that's AB. So now we just do the cos rule to find AC. So
And would you be confident doing that?
Yep.
Yeah, I think so. And you just remember to square root because it's a squared equals. I think you're fine for the rest of that. So how about this one?
Wait, so right. Those lines through C means what?
It's just they constructed a triangle, so those are just the working out lines. It just means that these two are the same length, which they also show. That this line is 6 centimeters and this line is 6 centimeters. So they used a pair of compasses to make this. That's all they're showing there.
So, well, we know that the triangle is an isosceles, and I don't know how that would help. We could do. Oh, I know. We could do sine rule to find that right angle C. So that would be. Wait, you want to find on top? So sine 40 over 6 times the 8 to get the sine. To get sine C, yep. And that gives you 0.85 reverse sine is 58.99.
So we'll do it. They said 1 decimal place. So what would that be to 1 decimal place?
To 1 decimal place, it'll be 59.0.
Yeah. Strangely.
Yeah, go on.
Strangely, this is an obtuse angle.
Yeah, so the fact that it's an isosceles means that the other side will be the same. You just do 180, take away that. So 180 take away 59 is 121.
Yeah. And so this one here is 121 degrees. And this one here is the 59 degrees. And so, yeah, because they're both 6. And so there's two triangles. There's one that has an acute angle, and then there's one that has an obtuse angle. And that's part of the reason why with sine equations, the second answer is 180 minus first.
Right.
Any questions there?
No, that's good.
Okay. That one's all right. Let me just take a look at this thing. P to R, I think this is similar. That looks very similar. The area of quadrilateral, that's similar. This one.
This one?
Nah. I think you're gonna be okay. It's just sine rule, but it's just been. What do they want? The distance between H and P. So you're just using cos rule and stuff. Yeah, that's okay. So this is the next thing. Okay, how about this?
Well, HG is equal to DC, so that'll be 12, and you can use Pythagoras to find FH. But we're doing A, right?
Yeah. So how do you?
A.
What are the numbers for Pythagoras?
It'll be 12 squared add 9 squared, which is 225. Square root is 15. That's AI. BH would be you would have to find.
So what was FH, sorry?
That is 15.
And what were the numbers for Pythagoras for it?
Oh. 12 and 9.
Okay, so that was 15.
And then BF is 14, so you do 15 squared plus 14 squared. Square root answer is square root 421.
Okay.
FC is 9 squared plus 14 squared. Square root is square root 277. Root 277 for F to C.
Okay.
And then C to E is the same as B to H, wouldn't it?
C to E.
Yeah, it would be the same.
Yes, it would be. Yeah. And so, how do you find how do you do part B?
Part B. Find the angle between. Okay, interesting. So they're trying to work out the angle between like on the line H to F, as if there was a line going down to D to F between there. So it'd be DFH.
Yeah.
Okay then. Well, the length of that is root 421, the diagonal. We know all three lengths, and we know one angle is right angled. So it'll just be trig to find angle.
And what was the
this
D?
side,
What was D to F?
E to F is root 421.
Yeah.
The F to M to H is 15, and D to M is 14.
Yeah. Okay. How do we get the angle?
Could do sine rule.
And because it's a right angled triangle, you can even use SOHCAHTOA, which will be easier. You could also use cosine rule, which is, more difficult. But
Yeah.
I think the simplest is SOHCAHTOA.
Okay, so I've kind of just been using sine rule and cos rule, and I've kind of forgotten how to use SOHCAHTOA.
So I think what's kind of awkward about it is you're kind of spoiled for choice because you got the 15 as well. What if I took away the 15?
It would be sine.
Yeah.
So you do sine theta is equal to the opposite over the hypotenuse.
Yeah.
Right. Okay. And that would be 14 divided by root 421.
Yeah.
It is, and then reverse sine of that.
Yeah.
And that gives you 43.03
degrees. And then for the others, it will be the same process. Any questions there?
No, that's right.
So I just want to leave this because it's going to get very cluttered, and it's already too cluttered. Let's see. Yeah, so let's do this one.
AC. Okay. First, we could find EC, that length.
Okay.
And that would just be simple Pythagoras, so 8 squared plus 12 squared. Square root answer is root 4 root 13.
Okay.
And then we have to find the length A to C, which would would you do it in could you just like imagine it was like a cuboid and then do A to C, or can you work out the A to D and then use Pythagoras to find that diagonal length, or are they the same lines?
So A to C, you now have a triangle. So you now have a right angled triangle.
5 squared plus 8 squared square rooted is
No. I think the triangle. So A, B, and C.
right. Right, yeah, we got two lengths. So we could do opposite and adjacent, which is tan.
Opposite and adjacent, yeah.
So
Hang on. So the right angle is at E. Yeah. Sorry. Yeah, go on.
Yeah, so you 5 over 4 root 13. Right. And then reverse tan the answer, which gives you 19.12.
19.1 degrees, and that was the inverse tan of 5 over 4 root 13.
No, it wasn't. It was the reverse tan of 5 root 13 over 52.
Where did that come from? Sorry, go on.
I did 5 divided by bracket 4 root 13 bracket.
And it just automatically rationalized the denominator, was it?
Maybe.
Yeah, same thing. Your calculator just automatically rationalized the denominator.
Yeah.
So okay, yeah, opposite over adjacent, and then you just inverse tan. That's fine. Any questions there?
No, that's good.
Okay, so 3D Pythagoras. Yeah, that's all it is. The length of A to C. I'm going to leave that one. So this one is the same idea. I think we might be okay for these. Calculate the angle that makes with the base. A to B makes with the base. That's the same idea. Yeah, same idea. And then this is their exam style question. Calculate the length of the diagonal B to D. That's okay. And then calculate the area of the triangle A, B, D. Oh, that's not bad. How would we calculate the area of the triangle ACE?
The triangle, what, the area?
Yeah.
Sine rule.
Even simpler. Right angled triangle.
Oh, half base times height.
Yeah, and you'd get the same thing if you did it the other way, because sine 90 is 1, and so you'd get a half times 5 times root 14 times 1. And this exam style question is the same thing. Yeah, you just do the because it makes a right angled triangle, it'll work out for you. Look at the size of angle B to A to D. It's the same idea. Okay, this is what I wanted to get to. Let's just see if we're good for it. Hang on. That's not very good. See, these aren't really. These are teaching style questions. How would you do question 9?
Question 9, discard a transformation that marks above. Reverses the x-axis.
Do you know what that's called?
flipping?
Reflection.
Reflection, yeah.
And so it's in the x direction. So the x's, plus x's and minus x's change place. So what's that? What is the mirror line?
It'll be a y, so it'll just be like down, yeah.
And so that one moves to there. That one moves to there. And so what is the mirror line?
0, y equal y, just y.
Yeah, reflection in the y-axis.
Yeah, in the y-axis.
Or in x equals 0, in the line x equals 0. How about part A up the top?
Part A, describe the transformation. That's the same. No, it's not. It's a reflection in the y in the x-axis.
Yeah, well done. How about... Oh, I'm not doing any of the silly stuff. How about the exam style question?
The exam style question. Here is this. What the? 190. 90 and 1 minus 1.
Yeah. How about Q?
360 0.
Yeah.
540 minus 1.
I think it's 90 plus 360, is it?
20. Yeah.
So what is that?
450.
450. 450 minus 1. Yeah. So this is repeating. Same y coordinate. Okay. All right. Okay, the equation of each of these graphs. So what type of graph is it? And write down its equation.
Right down each one. So the first one is going to be cos.
Yeah.
And it's going to be cos x is minus x.
It's so the cos graph. What has changed about the cos graph?
It's been flipped. It's reflection.
I think it was just moved down.
Moved down. Oh yeah, so it's been stretched and you times it. So it'd be like
I think
2 cos x.
I think it was just moved down. So it was just translated down.
Okay.
So it's usually so it usually looks it usually looks like that, and it's now been moved to like that. So what's happened there?
It's -1 in the y-axis. So it'd be y equals -1 cos x
So it'll be y equals cos x minus 1.
-1.
So it's outside the bracket, so it's not in the x direction. How about this one?
That is sine.
Yeah.
And it has just been moved up. So it's been moved up by 1. So it'd be y equals sine x plus, bracket +1.
Well done. And last one.
Last one is, it's moved up 2.
Yeah.
So it'd be y equals tan x +2.
Well done. +2. That's okay. What describe this transformation? The part B one. Just describe it.
That is there one? Oh wait, B. It would have moved 30 to the right.
So let's say, you know how this usually has the x of 30. So it usually has x is 180. After the transformation, x plus 30 equals 180. And so what is the new x?
210.
That would be if it was minus 30.
Oh right, yeah, because you do the opposites, so it'd be 150.
Yes, and so you're subtracting 30 from both sides, and that's why it's the opposite in the x direction. And so what's going to happen to the graph?
It's going to move 30 to the left.
Yeah, and do you know how you describe that fully?
Translation of minus 30, 0.
Well done. So the y, they've already brought it to the other side, so that works the way it's supposed to. So describe part C.
So it's moved translation minus 40, 0. Translation, then B is
hold on. Just part C.
part C plus 60, 0.
Yeah, fine. That's great. You have to match those up. You'll be fine. Describe this transformation. Y equals sine x became y equals 2 sine x.
Sorry, which bit are we doing?
So just describe.
Describe. It's stretch of 2.
Which direction?
In the y.
Yeah, so stretch y direction, scale factor of 2. How about question 9, part C?
We're doing C, yeah?
Yeah.
Describe it. It'll be a stretch in the x direction of 2. No, it'll be
The opposite?
right?
What would that be called? Stretch and compression?
Still just a stretch. So what would be the scale factor?
-2.
Which question are you looking at?
C.
Are you looking at 10C, is it?
Yeah, 10C.
Okay. So yeah, stretch, X direction. So let's say, so what is this? So you have the old X was 90 degrees for sine. So it now becomes 2X equals 90. So what is the new X?
45.
And so what's the scale factor?
A half.
Yeah. What about 9C?
9C would be a half in the y direction.
No.
That's not. Just -2.5 in the y.
Yeah, stretch y direction, scale factor -2. So you can have a negative scale factor. What would be part A?
Be a stretch in the same as divided by 3 is 1. Would be the same as time a stretch in the x direction of 0.33.
A third?
A third, yeah.
Yeah, scale factor a third. So it's always a reciprocal. Okay. Oh, that's fine. It's not too bad at all. What would be the Q, coordinates of Q for this one?
360.
360 would be here, I believe.
So it'd be 240. Sorry.
Yeah.
270 -1.
That's it. Great. So, stretch transformations. How do you feel about that? X half tick.
Yeah, they're at tick.
I think you're good. Yeah. Okay. Histograms. How do we do this?
So it'd be 15 times 6 to get the frequency.
It would be base times height. So it starts from 15. What does it stop at?
Stops at 20.
So it'll be like 3 separate bars. How about just the first bar?
The first bar is 3. Well, no. What's that? That's going to be every.
And my
4 is 1.
my guess is it's 16.
Yeah.
And so
15 to 16. 1 times 6 is 6.
So yeah. So I think you would do something like, so how would time work? So you let's say 15. So it's between 15 and 16, like that. And frequency is 6. Okay, what's next?
And then the next one would probably be like 16 to 18. And
Yeah.
18 to 21. So it'd be 2 times 7, which is 14.
Yeah.
And then 2 times 10 is 20. And then 5 times 3 is 15. And then 5 times 1 is 5.
Okay. How do you work out an estimate for the mean time taken?
Do you add all the frequencies up and no? Would you go to the median?
They wanted mean.
Not really sure what to do.
I would do it purely from the table.
You have to add up the frequencies and divide by. I'm not really sure.
So it's an estimate because you don't know the time for these 6 people. They could all be 15. They could be 15.1, 50.2.
Yeah.
What estimate would you use?
The middle.
Yeah. And
So
so
15.5.
And so you're saying those 6 people were all 15.5.
Yeah.
And so what would you do there?
6 times 15.5.
Yes. And so
14 times 17. 20 times 19. 15 times 22.5 and 5 times. Okay, yeah, I understand it. So,
sorry. Was I not using the midpoint? 17, 19.
so it'll be.
2.5.
I got 1,186,
Okay.
and then divided by. All the people, so 6, add 14, add 20, add 15, add 5. And that is 19.8.
19.8. Okay, so 19.8 minutes. What is the mode for this one?
The mode, the most often, the 18 to 20.
Is our average in there? Our mean?
No.
Between 18 and 20?
Oh wait, no, it is. Yeah.
Yeah, so we're probably okay. The median might be in there as well, so it looks like we're okay. If we got some crazy answer like 31 minutes or something, so that's a way just to check your answer.
Okay.
Yeah, so make a frequency table, and then get the mean from your frequency table. You can only estimate it by using the midpoint times frequency. So total of that over total frequency. Any questions there?
That's good.
Okay. Oh gosh. So brutal. Okay. I've got the frequency density. Okay, so this is quite a common one. How do we do this?
Sorry, we didn't. So to make the table, no, you don't. 5. Okay. 5. Okay, so the frequency density is frequency divided by the width, isn't it?
Yep.
So 0.5. 5 divided by 0.5, which is just 10.
Yes. So hang on. So the frequency is 5. So it's 0.5. Yeah. So it's 10. Okay. And then you would get the total. I think you're okay for there. How would you estimate the median? So let's say if we go back, how would you get an estimate for the median for this one?
The highest one.
And what is that?
No, wait. Estimated median. Yeah.
What was the total people?
The total people was 50 people.
I think it was 60, was it?
Might have been. Yes, it is.
So which person is the median person?
The 30th.
And where are they?
30th person is in between 18 and 20.
And so it would be the median?
18 to 20.
And could you get a closer estimate?
Go halfway between that.
Yeah.
19.
Yes. And so if you were asked like what group it's in, you could say 18 to 20. And if they asked you to estimate it, I mean, that's exactly in the middle. And so it would be 19. What if it was only a quarter of the way in? What if it was person 25? If these 5 people at the end weren't there or something. Or whatever. There was 10 fewer people.
That would make it about 22. It would still be in between 18 and 20.
So instead of it being halfway, what if it was a quarter of the way?
Or quarter. You could go halfway in between 16 and 18, which is 17.
So it should be a quarter of the way between 18 and 20?
16.5.
16.5 is a quarter of the way between 16 and 18. 18 and 20?
Oh, we mean 18.5.
Yeah, because like it's still in there. Let's take a look. We're gonna have medium height, a frequency table for the data, an estimate for the mean, and that was good. Okay, how many elephants are there in total? Estimate the median. Only way more than that. Draw a histogram. Mean, mass, median. What is the modal class for this one?
The modal class would be 750 to 800.
Yeah. That's it. Show modal working estimate. Yes. Histogram, mean, median, mode. And then it is the next thing. Yeah. How is that for you?
That was good.
So I'll call again at 1.
Okay then.